Okay, so what I did was I just went in and copied the worksheet down on regular paper so I could see it a little bit better, and so that I could write on it a little bit better. So when I'm doing the chemistry stuff, especially in the beginning as I'm learning it, I usually will have 3 colors and then a pencil to write with. The 3 colors and the pencil allow me to track how I'm distributing things. It helps me keep things in line. And then the pencil, obviously, because I'm going to make mistakes because, you know, life happens. The grid paper also helps me keep it in nice, straight, even lines. Again, this is just how I learned it in the beginning, and it helped me keep it straight. And so now I can do this part of the stoichiometry or the balancing equations part faster and more accurate because I'm able to track how it went and I can see how it's all developing. So I'm going to use pencil for the basic parts of it, and then as I go into the distribution of things, I will bring out the color. So before I get going, I'm going to write up here at the top. This is also in your notes. So with the PEMDAS, realistically, it's the parentheses that we're dealing with. Our exponents are going to become our subscripts. Because they don't have exponents in this part of chemistry. And then I'll do the multiply part. So we usually don't have divide or addition and subtraction until later when we get into equations. So looking at the simple iron and oxygen, if the number isn't listed, like this little 2 is listed, if there's no number, then it's just a 1. Because my pencil is probably not going to show up very well, I'm going to use the pink as my pencil. Again, there's no list, there's no number, so I'm just going to assume it's a 1. For my total in this molecule, I just add them up. So 1 plus 1 gives me 2. So there's 2 atoms total that are present. So I'm going to use the yellow to help me show how I distribute. So the big coefficients, get red. Remember, my coefficients are my number of molecules. And then my subscripts are my number of atoms. So in this hydrogen, sulfur, oxygen molecule, I have 2 of these molecules, but then I have 2 hydrogen that are inside of it. So if I were looking at this on a way to write this out, right? Because I want to look at how does this look. So 2H2SO4. That's like writing hydrogen and hydrogen, sulfur, oxygen, 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 oxygen. But then I would have to write that out twice because there's 2 molecules of it. So by writing it this way in this shortened formula, it's a way of writing out I have 2 sets of 2 hydrogens, a sulfur, and 4 oxygens. So looking at my number, that big coefficient of 2 is going to get distributed all the way across. So for my hydrogen, 2 times 2 gives me 4 hydrogens. For sulfur, 2 times 1 gives me 2 sulfurs. For oxygen, the 2 times the 4 gives me 8. And then to get my total number, I'm going to add 8 plus 4 gives me 12 plus 2 gives me 14. So my atom number total is 14. My number of molecules total is 2. So I'm going to move some stuff around on my desk so that I can push this up a little bit. And then we will keep going. So I'm going to put this, there we go. Now I can get all those in this shot. So moving on to number 3. There's no coefficient, so this one's pretty straightforward. The subscript is the one that's right next to it. It only affects the one to the left. So I have 8 carbons. I have 18 hydrogens. 18 plus 8 gives me 26 total atoms. And I get into this hydrogen sulfate. So the 2, remember, is going to distribute all the way across. So for hydrogen, 2 times 2 gives me 4. Sulfur, 2 times 1 gives me 2. For oxygen, 2 times 4 gives me 8. My total, again, 8 plus 2 plus 4 gives me 14. Looking at number 5. So 5 is interesting for a couple reasons. One, this little subscript is only going to affect what's to the left of it, so it only affects the oxygen molecule. And then Cl is chlorine, not iodine. When they write iodine, they'll typically do it with the capital, the hard lines on the I. So I'm going to distribute that 3 across. So for potassium, 3 times 1 gives me 3. For chlorine, 3 times 1 gives me 3. For oxygen, 3 times 3 gives me 9. When I add those things up, I get 9 plus 3 plus 3 gives me 15. My total number of atoms is 15. My total number of molecules is 3. So the potassium bromide, remember that 5 goes all the way across. So with my pen, which is really supposed to be my pencil, 5 times 1 for potassium gives me 5. For bromine, 5 times 1 gives me 5. I add those up. 5 plus 5 gives me 10. Number of molecules is 5. So the iron sulfate that's on the bottom, as we get into numbers that have coefficients and subscripts, these get to be a little tricky. So what I typically will do is take, I'm trying to see if I want to use a letter. No, we'll just go with this one. I will take the stuff in the parentheses and redistribute it across so that I don't have to think about it as I'm doing the other multiplication. So to get rid of this 2 on the outside, helps if I get it on screen and on camera. There we go. So to get the 2 out here on the outside of the parentheses, I'm going to get rid of it so that as I redistribute the big coefficient, I'm not caught up with the tiny mistakes that sometimes I make with math. So I'm going to cross it off. 2 times the 1 on sulfur gives me 2. 2 times the 4 for sulfur will give me 8. So I just rewrite it over it. This is why the pen colors can be helpful. And then I'm going to take my yellow and redistribute across. So as I start to move now, iron is 2 times 1 gives me 2 irons. For sulfur, 2 times that 2 that I distributed in gives me 4. And then 2 times the 8 that I distributed in gives me 16. To add them up, 2 plus 4 plus 16 gives me 22 atoms total. My number of molecules is 2. All right, so that's section A. Now, we're going to look in at section B. I'm going to have to move cameras around a little bit. Okay. So B was a little different because B had the grid for you to use. On some of them you did have extra, like there were a couple where there was an extra line that you didn't need, especially when we get down here at 7. That one's kind of funky. And then I think, oh, number 9 had a difference. We'll look at 9 here in a second too. So we did 1 and 2 in all the classes. They're pretty straightforward, so I'm going to skip straight to number 3. So for the lithium and the oxygen, lithium has a 2 as a subscript. Oxygen has a 1 because it's not noted of any other number. So then 2 plus 1 gives me 3, so there's 3 atoms total. On 4, lithium sulfate. Lithium has a 2 as a subscript. Sulfur has a 1. Oxygen has a 4. So I add those up. 2 plus 4 is 6. Plus 1 is 7. So there's 7 atoms total listed there. Number 5. So I'm listing these out. Remember, nitrogen, hydrogen, and chlorine. That wouldn't be Ci, it's Cl. So for nitrogen, there's 1 because it's no other numbers are noted. With the hydrogen, it's 4. Chlorine is 1. So to get the total, 1 plus 4 is 5, plus 1 is 6. So there's 6 atoms total. Number 6. I'm going to distribute that 2 all the way across. So for calcium, I'm going to do it once on number 6, and then I'm not going to do it going forward. I get the 2 times the 1 for calcium gives me 2. And 2 times 2 for chlorine gives me 4. So my total, 2 plus 4, gives me 6. So then let's look at number 7. This is where we kind of they start to get a little more difficult as we go down. There we go. So number 7, there's 2 hydrogens listed. So I'm going to list them separately and then add them up to get the total. Same thing with the carbons. So if there was a multiplication, if these were in parentheses, then I would be multiplying. But because they're just listed next to each other, I'm going to add them up. So my first hydrogen is a 2. Then I have 1 carbon. Make sure you put it at the carbon link, the carbon lettering as we put this down. I have 1 oxygen. I have another carbon, so I'm going to add that up. And then for hydrogen, I have another set of hydrogens, so I'm going to add those up. So 2 plus 2 hydrogens give me 4. There's 1 oxygen. 1 plus 1 carbon gives me 2. Then for my total, I'm going to add up 4 plus 1 is 5, 6, 7. So there's 7 atoms total. On number 8, this has got coefficient distribution and parentheses distribution. So again, I'm going to cross that 2 out. 2 times 1 oxygen gives me 2. 2 times 2 hydrogen gives me 2. Now I'm going to go in. 3 times 1 magnesium gives me 3. 3 times 2 oxygens give me 6. 3 times 2 hydrogens give me 6. Then I add up. 6 plus 3 gives me 12. So there's 12 atoms total. For the aluminum hydroxide, I'm going to distribute that 3 in. So that's 3 hydrogen, 3 oxygen, and I'll cross it off. So then now it's a listing game. There's 1 aluminum, there's 3 hydrogens, or 3 oxygens, sorry, and then 3 hydrogens. Adding it up, 3 plus 3 is 6, plus 1 gives me 7. Same thing over here with this iron and the carbon trioxide, carbon oxide, iron, carbon, and oxygen. Redistribute that 3 in. So 3 carbons, 3 times 3, give me 9. And now it's a listing game. So there's 2 irons, there's 3 carbons, and there are 9 oxygens. So 2 plus 3 is 5, plus 9 is 14. And then lastly, we get into these guys, and they aren't super difficult, but they get to be kind of weird. I am going to get a different color to do this bottom one with. Okay, so looking at my coefficients, it's going to go all the way across. So for my sodium, 2 times 1 gives me 2 sodiums. For carbon, 2 times 2 gives me 4 carbons. Hydrogens, 2 times 3 gives me 6 hydrogens. Oxygens, 2 times 2 gives me 4 oxygens. So 2 plus 4 plus 6 plus 4 gives me 16 atoms total. And full disclosure, I have a calculator over here because I'm smart, but I'm doing that real fast and I'm not that good. So with this ammonia phosphate, I'm going to redistribute this 3 in. So I'm going to cross it off. 3 nitrogens. 3 times 4 gives me 12. So now I'm just a listing game. Nitrogens, there's 3. Hydrogens, there's 12. Phosphorus, there's 1. Oxygen, there's 4. So now I add up 3 plus 12 plus 1 plus 4 gives me 20. So we're getting a little more difficult. Now we're going to look at the back of the worksheet. I'm going to go to the next page of my notes that I've made. I'm going to reset the camera. We try to fit these all in. Okay. So on the back, I'm going to try to go about the same pace, but I'm not going to do as I did before with when I multiply, like so on number 2, it won't be 4 times 1, and I'll just write a 4 in there. So on number 1, the sodium, oxygen, and hydrogen. So remember, no numbers mean that it isn't understood 1. So 1 sodium, 1 oxygen, 1 oxygen, and 1 hydrogen. On this worksheet, it doesn't have you, or the section of the worksheet, it doesn't have you creating a total list. It just wants you to list them and count them out. So on number 2, I will draw my arrows in because that helps my brain. So for hydrogens, 4 times 1 gives me 4. Nitrogen, 4 times 1 gives me 4. For oxygen, 4 times 3 gives me 12. Number 3 is magnesium chloride. There's 1 magnesium and 2 chlorines. On number 4, with lithium, 4 times 2. My brain really just went to sleep. It's 8. Oxygen, 4 times 1 gives me 4. Number 5, the sodium hydroxide. So for sodium, 2 times 1 gives me 2. Oxygen, 2 times 1 gives me 2. Hydrogen, 2 times 1 gives me 2. Number 6, with lithium, little tiny subscript of 2 tells me there's 2. With sulfur, no number means it's a 1. Oxygen is a 4. Now I'm going to move it up. So number 7, remember I'm going to distribute that 3 across. So for hydrogen, 3 times 2 is 6. Oxygen, 3 times 1 is 3. Easy peasy. Number 8, for sodium, no number means it's a 1. Carbon, little subscript of a 2. Hydrogen, little subscript of a 3. Oxygen, little subscript of a 2. Number 9, redistribute that 3 all the way across. So for aluminum, 3 times 2 is 6. For oxygen, 3 times 3 is 9. Number 10, on the nitrogen, no number means it's a 1. Hydrogen has a tiny 4. Chlorine has a 1. On number 11, for zinc, 5 times 1 gives me 5. Sulfur, 5 times 1 gives me 5. Oxygen, 5 times 4 gives me 20. This again is why I do those numbers, because otherwise it would look like 0 to 0. So that's partially why I put my numbers like that. All right, on the last section before I have to move my pictures around. For carbon, 7 times 2 is 14. 7 times 2 for sulfur is 14. Hopefully this is starting to become a little easier, or you're at least starting to see the pattern. So for 13, 14, and 15, I've got those parentheses and numbers on the outside, the little subscripts on the outside. So I'm going to redistribute those first. So I'm going to cross out that 2. 2 times 1 for phosphorus is 2. 2 times 4 for oxygen is 8. There's a 2 in front of the strontium, so I'm going to distribute that over. And now I'm just going to do the math. So for strontium, 2 times 3 gives me 6. For phosphorus, 2 times 2 gives me 4. For oxygen, 2 times 8 gives me 16. Aluminum hydroxide, it's got a 3 on the outside, so I'm going to redistribute 3 and 3. It's got a big 4 at the front, so I'm going to redistribute all the way across. Aluminum, 4 times 1 is 4. Oxygen, 4 times 3 is 12. My brain, yeah. It's 11 o'clock, so I'm getting sleepy. Hydrogen, 4 times 3 gives me 12. And then the last one, I'm going to scoot this over just so we can see a little bit better. On this section anyway. I'm going to redistribute this 2, so I'm going to cross it out. 2 times 2 gives me 4. 2 times 2 gives me 6. 2 times 2 gives me 4. There's no coefficient, so now it's just a listing game. Calcium is a 1. Carbon is a 4. Hydrogen is a 6. Oxygen is a 4. The last part. This is the last 3 that are on the counting atoms part, and then the bottom parts are the if it's balanced or not. So first things first, I'm going to get rid of this number on the outside of the parentheses, redistribute it. So for sulfur, 3 times 1 gives me 3, 3 times 3 gives me 9. That big 4 is going to get distributed all the way across. So for aluminum, 4 times 2 gives me 8. Sulfur, 4 times 3 gives me 12. And then the last one, oxygen, 4 times 9 gives me 36. I'm going to get rid of this 3 on the outside. So 3 times 1 nitrogen, 3 times 4 gives me 12 for the hydrogen. Now I distribute that 2 all the way across. So for nitrogen, 2 times 3 gives me 6. For hydrogen, 2 times 12 is 24. For phosphorus, 2 times 1 gives me 2. And then oxygen on the outside is 2 times 4 gives me 8. Magnesium oxide, or hydroxide, sorry. I'm going to go ahead and distribute that 2 in. So 2 and 2. I'm going to show my 4 being distributed across. So for magnesium, 4 times 1 gives me 4. Oxygen, 4 times 2 gives me 8. Hydrogen, 4 times 2 gives me 8. So then the last little section, oh, I'm trying to take my camera with me, are the balanced or not. So I'm going to do this the long way and show how to write them out, because I feel like some of us need to know how I'm deciding this. And then I'm going to go back and show the quick way. But I need you to know how to do it the long way, just in case. So if we were doing this like the really, really long way, I would make you come in and we would put boxes around the molecules to divide them up so that we don't count extras that don't need to be there. So this is just a way for us to slow down, because it's like you count the box and then you move to the next box. So for our purposes, you wouldn't have to do that, but I'm going to show you how to do that anyway. So on the balanced or not, remember, for it to be balanced, all the elements are the same before and after. So I'm going to list, what elements do I have? I have iron and oxygen. I have iron and oxygen. So then I just count. Iron, no number listed, so it's a 1. Oxygen is a 2. After the yield, so the product that's made, iron, no number listed, is a 1. Oxygen, no number listed, is a 1. Now I check. Iron, 1 and 1 the same? Yes. Oxygen, 2 and 1 the same? No. So this is considered unbalanced. Now the part where it went, let me get that purple, there we go, that's better. Move on to number 2. I'm going to list what I have. Strontium, oxygen, strontium, oxygen. So I'm just listing what's present. I put a line on the yield, so I look at the reactant side and then I look at the product side. Now I'm going to go count. Strontium, no number listed, is a 1. Oxygen, 2. After the yield, my product, strontium, no number listed, 1. Strontium, 2. Now I check. Strontium 1, yes. Oxygen 2, yes. So on number 2, it would be balanced, because both of the numbers are the same before and after the yield. So looking at the third one, potassium, bromide, potassium, bromide. Now I count. Potassium before the yield, no number listed, a 1. Bromine, 2. After the yield, potassium, a 1. Bromine, 1. Now I check. 1 and 1, potassium the same? Yes. Bromine, 2 and 1 the same? No. So this one is unbalanced. Last but not least, lead and iodine. Lead and iodine. So I count them up. Lead before, 1. Iodine before, 3. Lead before, or lead after, 1. Iodine after, 3. Now I check. 1 and 1 the same? Yes. Iodine, 3 and 3 the same? Yes. So this one is balanced. Now the quick and easy way to do this, if you were looking for a faster pattern finder way. So some of my friends, you guys are really good at finding patterns. If I look at this first one, there is a 2 for that oxygen and not for the second. So if I'm just skimming, I can already tell that's not balanced. If I'm skimming, no subscript, 2, 2. Okay, good. Potassium, there's a little subscript of a 2 for bromine. If I check bromine, no subscript, so that's unbalanced. Sometimes you need to do the math of it. You need to work it all the way out. Other times when they're little equations like this and you can easily check it, it might just be faster to check and see if the subscripts are going to match. Okay, so hopefully that helps you and you can submit your homework.